Hello, my dear NEET students, IIT aspirants, CBSE students. Welcome to BHANU MOORTHY Academy of Objective Physics. This is BMS Academy of Conceptual Oriented Coaching Center. It is situated in VANASTHALIPURAM, HARIHARAPURAM Colony, Hyderabad. So, in the last week, in tips number 3, we discussed about the direction of magnetic field around a current carrying conductor in moving charges and magnetism chapter in physics. Now, in this tips number 4, on the behalf of parents and students' request, I am going to explain or project some magnitudes of magnetic induction around a current carrying conductor. So, gunshot formulas, gunshot concepts, gunshot applications, and the previous entrance questions we are discussing in this tips number 4 video class. Okay, listen carefully. If you like this video, share. Like, share and subscribe and viral this video to all your friends circle. Okay, so let us start quickly. Now, this is Biot-Savart law. This is a current carrying conductor. It is a infinitely long non-linear conductor. So this is infinitely long non-linear conductor carrying current. It is divided into number of sub-elements now. One of the element DL is considered there. Okay, due to this element, current element induction, because it produces magnetic field in its surroundings. In this magnetic field, a point is expected there at that point, which is situated at a distance r. At this point, magnetic induction depends on 4 factors now. So parameters now here, as strength of the current increases, magnetic induction increases. As the length of DL increases, next induction increases. And angle, as angle of sine of angle increases, B increases, and as the distance increases from the conductor, so then induction reduces. So this is Biot-Savart law, magnitude of magnetic induction. Okay, right, now this is a vector form of magnetic induction due to Biot-Savart law is mu naught I by 4 pi into dl bar cross r bar by r cube. So this is into the plane because it is a conductor, and the right side, this is the conductor here you see, and this is into the paper. So in the previous class, tips number 3, we discussed about the directions. Now magnetic induction is into the paper. Okay. Now this question is asked in 1990 AAPMT. Okay. So this is a vector form of Biot-Savart law. Direct formula is given to you. So one question is completed. Now let us go to another application of Biot-Savart law. Okay. This is direct Biot-Savart law. It is one of the applications of Biot-Savart law. Now we are considering what a finite length, a conductor, a current carrying straight conductor of finite length we are discussing now. It has end 1 and end 2. Okay, due to this current carry, whenever current passes through it, it behaves like a torchlight. Okay, it produces magnetic field in surroundings at a particular point P at a distance r, perpendicular distance r. We want magnetic induction. Okay, this magnetic induction is into the paper again because according to thumb rule, so lines are into the paper. Okay, now. So magnetic induction formula. So mu naught I by 4 pi r. End 1 is making an angle theta 1, end 2 is making an angle theta 2. At the point here, then total induction at this point is 2 inductions are there. So due to this end, 1 induction, due to another end, another induction. Both inductions are into the paper. That's why we are adding those two. Sin theta 1 plus sin theta 2. This is a net magnetic induction due to a current carrying straight wire of finite length. Okay. Now its extension is this one. Its extension. This is a triangular current carrying plane it is. So through which current I is passing here. So when current I is passing through a triangular plane having 3 sides now. So due to one side, end 1 here, end 2 here, the angles made by these 2 ends at this center, we want magnetic induction at the center of it. Okay, of the triangle. So let us consider one side only. So it has 2 ends now, end 1, end 2 like this. Okay, so this end 1 is making an angle 60, end 2 also making angle 60. Okay, so then total induction is mu naught I by 4 pi r, just like this. Sin theta 1 means 60 here, theta 2 means 60. Then this is for only one side. Okay, now such that this triangle is having 3 sides. So total magnetic induction is 3 times to this value. If you calculate r value here, a by 2 root 3. Because this is a median from this corner to this one. Median is root 3 by 2a. We know that everybody. Okay, so 1/3 of this distance is nothing but r. 1/3 of the median value. That is a by 2 root 3. If you substitute this value in the place of r, you will get this value. So 18 times mu naught I by 4 pi a. So this is the gunshot formula. We are expecting in 2024 entrance examination by giving current, by giving perpendicular distance, okay, and or side length side length is A here. By giving side length A, so they can ask magnetic induction at the center of the equilateral triangle. Okay, it's a current carrying triangular conductor. Now, second application of this finite length is square. So find the magnetic induction at the center of the square plate, at the center of the square coil, okay, of side length A. This is the side length A, right? Now, at the center, the two ends, first let us discuss about the induction due to first side. Okay, end 1, end 2, these two ends are making angles here, 45 degrees, 45 degrees here. Then if you substitute here, you will get magnetic induction due to one side only. Okay, like that 4 sides are there. So 4 times this value represents this value. Okay, so A value here or R value here A by 2. So if you substitute R equals to A by 2 in this formula, then you can get A through 2 times mu naught I by 4 pi A. So this is the expression for magnetic induction. My dear NEET students, you observe carefully, these are called as gunshot formulas. In this academy, we are going to discuss gunshot formulas and gunshot applications, so which we are going to expect in 2024 entrance examination. Okay, so another application is, so another application. This is current carrying wire of infinite length. In the previous class, we discussed finite length, okay, triangle and square. But here, a current carrying conductor of infinite length, okay, so dash, 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 okay, infinite length. So then due to this current carrying conductor induction, at this point we want. So what formula we are selecting here? End 1 is making an angle 90 degrees because as compared to infinite distance, this angle increases, becomes 90 here. Comparing to infinity, this angle is 90. Here also, this angle increases. So due to infinite end 1, so this angle is also 90 degrees. Then sin 90 plus sin 90, that is 2. 2 divided by 2 pi r, 4 pi r. Then you will get mu naught I by 2 pi r. It is also called as Ampere's law. Okay. Now, in this case, in 1996, they asked one question from this concept. What is that? At a distance of 4 centimeter, the induction is B1. At a distance is 12 centimeters, what is the induction? So then you have to select this formula. Induction is inversely proportional to perpendicular distance. Okay, B1 by B2, R2 by R1. So this question was asked in 1996. My dear NEET students, you try to understand here. Okay. Now it's time for us to discuss about previous entrance examination questions. In 2023, what type of questions they asked here? Let us discuss. So this is a way of explanation in this academy. Now those who are willing to join in this institution, we are conducting tuition classes, online classes in the morning hours and in the evening hours. Those who are willing to join in this institution, go to these numbers, okay, so dial these numbers and you can join in our tutorial classes, okay, so online tutorial classes, wherever you are, so you just connect with this number, then you can hear my online classes, live classes. So direct formulas I will give and problems I will let us discuss. And some more important point, we are going to announce, we are going to very good news it is for all NEET students. Because this is very good news actually. So I am going to release some chapter-wise courses now. I am releasing some chapter-wise courses to those who are willing to purchase. So you go to download this app now, okay, which is mentioned in the description. Okay, after pressing after download this my app actually. So then you can purchase all those chapter-wise courses now. I am going to release as soon as possible. I think most probably in the month of August 10th, I am going to release one chapter-wise courses now. So those courses contain what? Number of gunshot formulas. Nearly each and every chapter contains 50 gunshot formulas, gunshot applications, almost all 50 gunshot formulas, and previous entrance questions related to those gunshot formulas. So it is very useful to the students, those who are purchasing my online courses. Okay, so chapter wise I am going to release. Okay, you purchase that, go through the app link. Okay, then download the link, then try to purchase those courses now. Okay, so let us go to 2023. In 2023, what type of questions they asked? Now let us discuss. Now, this is x-axis here. x-axis it is, one conductor is placed here, so carrying some current I, okay, some current I here, it is introduced in the magnetic induction B, okay, magnetic induction B is given as 2I bar plus 3J bar minus 4K bar. Okay, this is the magnetic induction. In this magnetic field, this conductor is placed along x-axis. Okay, its length is capital L, its current carrying is capital I. Question is what? It is placed along x-axis. The wire is placed along x-axis. So this question is asked in 2023. So what is the force acting on the conductor? That is the question. What is the magnitude of force acting on the conductor? So that is 5IL. This is a magnitude of magnetic induction force acting on the conductor. So actually force formula equals to I into L bar cross B bar. Okay, so this I is given as I, capital I, L means here along x-axis Li bar, okay, this is Li bar, cross B bar is given there, 2I bar plus 3J bar minus 4K bar. My dear NEET students, you try to understand, this is nothing but cross product, okay, if you know cross product, you can do the answer now. So I into I cross I 0, okay, I cross I 0, so I cross J, that is K bar. So L into 3L, okay, this is J bar. I cross J is nothing but K bar. I cross J is nothing but K bar. Okay, now I cross K minus J bar. Recognize, my dear NEET students. I cross K is nothing but minus J bar. So already minus is there. So minus of minus. So plus then L into 4. So 4L, this is what? J bar. I cross K is nothing but minus J bar. Already minus is there. Minus of minus plus. So that's why plus 4L J bar. My dear NEET aspirants. So this is 4Li J bar plus 3Li K bar. So this is the answer. Force acting on this conductor placed along x-axis, and current passing is I, length of the conductor is L, then it is placed in the magnetic field. What is the force acting on the conductor? So very simple question they asked in 23 examination. So what is the magnitude of this value? Under root of 4L whole square, 4Li whole square plus 3Li whole square. So final answer is 5Li. So this is the answer. Okay, root 5IL is given, 5IL is given, so 5IL is the correct answer. So my dear students, this is asked in 2023 entrance examination. Okay. So next, our next question is, so such type of beautiful questions we can discuss in this academy. If you are interested, so to join in this institution, go to that number, okay? And if you want to purchase my online courses, chapter wise online courses, now you go download that app which is mentioned in the description, okay? Now, what is another one? A conductor is there. It is placed in the uniform magnetic field of 0.7 Tesla. A conductor, straight conductor, carrying some current. Its length is given as 2 meters. It is placed in uniform magnetic field of induction 0.7 Tesla. Okay, so some current is passed here. Then it is placed in A, suspended horizontally in A. Now question is, how much current should be passed through that wire so that it remains horizontal, it remains stationary, it remains equilibrium, it does not fall down. At what current it does not fall down? So its mass also is given there, 250 grams. It is this question also 2023. Last year only they asked this question. So a conductor, a straight conductor is held horizontally in the air. Okay, it is placed in the magnetic field of uniform magnetic field of induction 0.7 Tesla. Okay, its mass is given 250 grams. Its length is given 2 meters. Now, question is, how much current, either this direction or this direction, how much current should be passed through that wire so that the wire remains stationary? Remains stationary. What is the condition? Means balancing condition, my dear students. So why it is not falling down? Because forces are balancing now. So weight of the wire mg balances with the upward bill. BIL is the force acting on the conductor in the upward direction, because the current is passing in the right side direction, then magnetic field will be upward. Okay, if the thumb represents current direction, magnetic field will be upward direction. So that's why current should be passed along eastwards. So in what direction current should be passed? Eastwards. So that's why then magnetic field will be upward. The four fingers represent magnetic field. So Bill balances with 4 mg. So BIL equals to mg. From this equation, we can find out what here I equals to mg by BL. So G value is taken as 9.8. My dear students, so this is the question. Now they asked in 23 examination. So like that in this institution. One more question I am going to give to you. It is also asked in I think it is 21 question. Okay. So beautiful concepts. From this chapter nearly 2 questions will come out of 45. Because this is a very, very important chapter. That's why parents and students are asking me to release some beautiful concepts in this chapter now. Because we are expecting 2 questions at least from this moving charges and magnetic field. So as soon as possible I am going to release courses now, chapter wise courses. They contain gunshot formulas, nearly 50 formulas. I framed nearly 50 formulas. Okay, which are very expectable in examination, and some important previous questions I mentioned in that course, and also some important gunshot problems I mentioned model wise. From one question from each and every model I framed, and I am going to project that what is that online course. So you purchase them, then you will get maximum benefit for the examination 2024 NEET. Okay, so this is a thick cable wire. So this is called thick cable wire. So it is nothing but cylinder. It's a thick cable wire, is nothing but cylinder. Okay, so this cylinder is having some axis now. This is called axis. Its radius is given as capital R. Capital R is the radius of the thick cable wire. It is almost all cylindrical shape. It is placed vertically. It is having some its own axis now. So question is what? Its radius is given there. How the magnetic induction? Actually this conductor also, because when current passes through this conductor, then it produces magnetic field in its surroundings. You know that very well. Question is now, what is the variation now? How this magnetic field varies with respect to distance from the axis of the cylinder? Well, that is the question. 4 graphs are mentioned there. One of the graphs we are expecting like this. Okay, so this is one of the graph. So B is taken on y-axis and R is taken on x-axis. On the axis and exactly B equal to 0, because along the axis magnetic induction 0 according to Biot-Savart law. Okay, on the y or along the y magnetic induction 0, already I mentioned in previous tips number 3. Okay, so you go through that video also. Okay, you always must be in touch with my video classes. From now onwards I am going to eject number of video classes alternatively. So frequently I am going to release. You must be in touch with all those video classes. Then you can have maximum awareness in the subject. Okay, at the same time purchase my online courses. Okay. So this is on the axis magnetic induction is 0. Inside at a distance small r. So magnetic induction formula mu naught I small r divided by 4 pi capital R square. So this is the formula B inside. Inside the magnetic field, inside the cylinder, magnetic field formula mu naught I small r divided by 4 pi into capital R square. This is the gunshot formula. From this gunshot formula, they asked this question. Okay, so now as towards here, be on the surface. On the surface means small r equals to capital R. If small r becomes capital R here, then it becomes B on magnetic induction on the surface. So that equals to mu naught I into capital R by 4 pi capital R square. One r gets cancelled, mu naught I by 4 pi capital R. So on the surface of the cylindrical surface, from the axis on the surface, magnetic induction formula. So what it indicates now gradually increases from axis to surface. Now outside, now what happens? Outside this what happens now? At a distance r outside here, this is called B outside. So B outside formula small r value you can put mu naught I here divided by small r divided by 4 pi small r square. 4 pi small r square here. So then r gets cancelled. What you will get? Mu naught I by 4 pi small r. So inversely proportional. So outside the cylindrical surface, the magnetic induction varies inversely with the distance. But inside it varies with directly to r. Inside it varies directly. So B proportional to r. That's why this is the graph directly proportional inside. And outside here it is inversely proportional to B. Outside is inversely proportional to R. So I have given this relation outside B, outside inversely to R. So this question also came in 2023 entrance examination. My dear NEET students, go through all these previous entrance questions. So and go through all gunshot questions. Then you will get perfection. So from this chapter we are expecting minimum 2 questions, maximum 3 questions. Okay. If you follow my online courses, you will get the maximum benefit. Bye. See you in the next video class, tips number 5. I am going to present some more important, beautiful concepts and gunshot formulas in tips number 5. I am going to release day after tomorrow. So keep on touch with my video classes always and try to purchase my online courses. You will get the maximum benefit, okay, from me. So it is given in the description. You download that app and go try to purchase those. So wishing you all the best, my dear NEET students, for entrance examination 2024. Bye. See you in the next video class, tips number 5. See you then.